Assalamualaikum guys. In this video we're going to talk about the last part of application in dot and cross product, which is distance from a point to a plane. Alright, so basically we want to find the distance of any point that is above a plane. So we have a plane here and we have, let's say, point P1, and we want to look the distance, right? Meaning we need to measure this line represented by capital D. Okay, so the way to measure this, we are going to use a vector, one other application of vector to help us in measuring this line. Right? The name of the application is projection, if you can remember. So assuming that we have this vector, we will project this vector to this line, and then we will use the projection formula to look for this length, and after that we should be able to get the distance. Okay, but we're not going to use the formula directly. Let us revise a bit on projection. So this is projection, where you have vector B, and the shadow of vector B on vector A that is perpendicular is known as a projection of B. Assume that you try to shoot a light from above, right? From above B here, and you'll see that this, you will have a shadow of B on top of A, right? So that is a projection. So by using the formula of component here, B onto A, which is this, we should be able to find the length of the shadow of B on A. So for this question, component of B onto A, you have a product of AB, actually a dot product of AB over the magnitude of A. We are going to apply the same formula, which is this, right? The same formula, right? We are going to look for the projection of B on N. Okay, projection of B on N. So the measurement will be the length will be on B for B on N. So we are going to find the dot product of NB over with the length of N, right? So the dot product, by the way, the component of N is ABC. The component of B here is P vector P0 to P1. In other words, we will subtract component P1 to P0, which is X minus X0, Y minus Y0, and Z minus Z0. Okay, and to get the dot product, we should multiply every component, X with X, right, which is A times X minus X0 plus B times Y minus Y0, and C times Z minus Z0. So you will have this. As for the length of N, we'll just use the formula of length here. Okay, so for this one, we'll expand it and we'll get this. And lastly, this for this one, right, this is actually an equation, right, for this is the component for P0, and as you can see here, P0 is on a plane, and because of that, the coordinate of P0 should satisfy the equation of the plane, which is in general should have A plus B plus C and plus D, right? By the way, this is the general formula of equation of planes. Okay, being that said, the equation should be, for this one, the equation of plane should be AX0 plus BY0 plus CZ0 plus D equal to 0. So we can then substitute all of this Right? If we move d to the right hand side, we'll get negative d. So ax plus by plus cz minus negative d, or ax plus by plus cz plus d over with this. This is how we get the formula. And what's more important is on how to use this formula. Okay, let's discuss exercise 3.15. Okay, so we do have find the distance from point A to the plane x minus 2y minus 2z equal to 1. Right? So we have one point and we want to measure it, right? The distance to this plane. So in other words, this is what the question are asking about. We have point A, we have plane. So this is what we want to look at. The distance A to this plane. Alright. So let's try to calculate that. Okay. So the two most important things that you need to know in finding a distance is this. We need to know the normal vector on the plane, and we need to have the point that we want to compare it with. Okay, so for this question, they give us actually directly that point. Let's revise a bit on how I get this normal vector. Right, we simply look at the equation and we'll find out the value that attached to the first the variables of x, y, and z. So we have 1, -2, and -2. So that's become my normal vector. And then we have point A, which is 285. Okay. Now let's substitute all of this in our formula of D. So just substitute this formula. A, B, and C is for 1, -2, and x, y, and z is for 285, and then S for D. Right? Notice that this is positive and I put it as a negative. Right? Because by right, okay, the D here is negative. Right? So just a tips. Right? Put back D to left hand side to see what is the symbol here. So it is -1. Right? So you have this as your answer. Okay. Now let's look at our next question. Find the distance between parallel planes, this and this. In other words, they now give us a question that is not quite direct. Right? By right, we should know these two information: a normal vector and a point. As for this one, they give us two parallel planes. Let me show you. This is the two parallel plane. So they want us to find the distance between these two planes. Right? The problem is, by looking at these two plane, we can only extract an information of normal vector. Right? If you want to extract it directly, we'll know that this normal vector is -1, -2, 1, and the normal vector of this one is 3, 6, -3. But as we have discussed before, in order for us to find a distance, you'll need to have one normal vector and the other should be a point. So how to get that information? So the way is to use one of the plane, right, as to find the normal vector. Let's say we choose this one. So the normal vector for this one will be, let me just delete this first. The normal vector for this one is 3, 6, and -3. Alright, and as for this one, we will use the parallel planes, which is this one, right, and find the point, right? We have to find the point from that is actually on this plane. So how to find the point? Just by using the basic idea, right, of finding Cartesian coordinate on any plane. Let's say that in a situation of x equal to 0 and y also equal to 0, what will be the z on this plane? So we'll just substitute everything. We should get z equal to 1. In other words, in a situation where x equal to 0 and y equal to 0, z is 1 for this plane. So now we have 1 point that sit on that plane, right? So the next thing is to just compute d using the information that we have. So we have A, B, C here, 3, 6, -3, and for the point is 0, 0, 1, right? And for D, notice that I'm using -4, right? Because we are comparing the point here with plane on this one, which is 3, 6, -3. We should also use the D on that plane, which is 4 on the left hand side is -4. Okay, so just calculate everything. So you'll get 7 over 54 as the answer, right? So this is how you calculate a distance of a point from plane, right? Thank you.